in today's video, we'll take a look at how to manage multiple pipes, because I've seen this question being asked time and time again, where people had to create multiple pipes and they didn't know what's going on or what's up, which pipes they had to close or which pipes they didn't have to close. So we're gonna start off with a simple exercise. I'm gonna actually pull up my little blackboard here, and in this exercise I want to create, well, 3 processes in total, so 2 forks. Let's say one here. Let's actually make it a bit smaller, we don't need them to be large. Another one here and another one here. Okay, and well, this is going to be our main process. I'm going to note it down with a dot here, and this is its child processes. So I'm going to have 2 child processes with the same parent. That's going to be our program, and what I want is to pass an int around all the processes. So I'm going to want to have, let's note it down with a green here. I want to have this guy create an x that has the value, let's say 0, and pass it to this process, right? Pass this x to this process, and then this process adds 5 to it, so plus 5, and passes to this process, this x plus 5, and then also this process does that exact same thing where it adds 5 to it, and then at the end this process sends the result back to the main process, right? And basically this x variable went through every single process, and at each step it got added 5. So at the end we should see here 10 in our terminal or something like that. How many pipes do we need for this exercise, and how or which one do we need to close? That's the question. Well, for starters, we definitely need 3 pipes, right? Because, well, first, pipes are unidirectional, and, well, they represent a link between 2 processes. And in this case, we have 3 arrows. In every case, we have to send one integer to another. Okay, so we can say that we need 3 pipes. Okay, but then where should we actually open those pipes? Well, for simplicity's sake, I'm gonna open all the pipes on the parent process, so right here. And how many file descriptors does that amount to? Well, we're gonna have 3 pipes, and each pipe has 2 file descriptors, a read and a write end. So I'm gonna have 6 in total file descriptors. Okay, so I'm gonna have 6 in total in here in the main process. 6, not 7, and just like that. Now the main key about this program is that those file descriptors are going to be inherited by the child processes. So each of these are also gonna have those 6, or a copy of those 6 file descriptors of their own. So we're actually gonna have in total, well, 6 times 3, which is 18 file descriptors. What does that mean for our program? Well, that means that we are gonna have to call the close function 18 times in the whole C source code. And this is the most important part when dealing with multiple pipes, is with this inheritance of file descriptors and then closing all of them up, because you don't want to let those file descriptors be opened. As you've seen in the previous video, it does cause sometimes quite a few problems. So in this case, we'd want to close all of them. That means 18 close calls. That's an important information. All right, let's get around to implementing this. So to start off, as I said, I want the pipes to be opened on the parent or the main process. So it's going to be, well, I'm gonna have here int fd. Well, since it's not gonna be just 1 pipe, it's gonna be 3 pipes. I'm gonna have fd of 3 of 2. And then we're gonna have an I here for a for loop for I equals 0, I less than 3 to create 3 pipes. And if pipe of fd of I this time is less than 0, then, well, I guess we can just return an error code. Usually it shouldn't happen, so you don't have to worry about it, but if it does happen, don't treat this error like I'm doing right now, because, well, if, let's say, 2 of the pipes already opened and the 3rd pipe failed to open, you should actually treat this case where you should close the other remaining pipes. But in here, I'm not gonna do that. I'm gonna skip that because it's gonna be quite a lot of code otherwise, and it's not the point of this video. So we have opened the pipes. Next up, we should start by forking every single each of those processes. So I'm gonna start with int process ID 1 equals fork. If the fork fails, so if PID1 is less than 0, then I'm just gonna return 2. Again, here you should close the pipes before returning, but that's another story. If PID1 equals 0, that means that we're in the child process number 1. If we're in the child process number 1, now we have to decide which pipes are going to be used for reading and writing, and which pipes we have to close straight away. Before we get into closing and opening the file descriptors, we should actually note which are going to be used for which process. So here we have that FD array. So we have FD of 3 of 2, right? So this is our array, and I'm actually gonna put it, let's see, down here. I think it's a good place for it. And in here we have 3 pipes, 6 file descriptors, and we need to assign to each end a file descriptor so that we know what we're working with. Well, for starters, I guess we can say that this guy is FD of 0. Let me actually make this a bit smaller. There we go. FD of 0 of, well, we need to write from this process to this process. So this end is really FD of 0 of 1, right? Because we want to have the right end here. So the read end is going to be here, FD of 0 for this pipe. Okay, so that's one pipe. See, FD of 0, that coincides. That means that is the same pipe. And here, I guess we can say it's FD of 1 because it is the writing end. It has to be the writing end for it. Then down here, we're gonna have FD of, well, it's the same pipe, it's just the reading end because it's gonna read in this process. And then here we have the last pipe, so FD of 2, and we're gonna write to it. So if we have here FD of 2 of 1, and let me move these down here. Okay, and lastly, it's this end, which should be FD of 2 of 0. So this would be our architecture. So we're gonna have to decide which file descriptors we do need and which we don't need. In this case, we're gonna focus on this one because this is the process that we have created right now. And for this process, all we need to know is that we need to leave FD of 0, 0 opened and FD of 1, 1 opened. Everything else is useless for this process. So for this one, we're gonna have to close everything that is not FD 00 or FD 11. So here we have FD or close of FD of 01, close FD of 10, and we're also gonna close everything from the third pipe. We don't actually do anything with that pipe, so we can just simply close it. Okay, that's amazing. Next up, what we need to do is, well, here we know that we're gonna have to read from FD of 00. So we simply enough, we do that. So I'm gonna say read of FD 00 into an X that we're gonna actually define up here, int X, size of int, because we only read an int. And I guess we should actually do something like an if it's less than 0, that we know that something bad happens, and then just return an error code, let's say 3 here, and that's all. So that was the read operation. And then, as I said, I wanted to add 5 to every single X that we get. So I'm gonna just say X plus equal 5, but that's not enough. We also have to write it to something else. I'm gonna write it to our FD11. And then, of course, I'm gonna write from X and size of int. This is pretty basic. if write is less than 0, again just do the same thing where you return an error code. And that's almost everything, except, well, we have to close all the file descriptors before the process finishes its execution. So I'm gonna have to close fd of 0, 0 and also close fd of 1, 1 once I'm done using it. So this is very important. And lastly, I also don't want really, once the process, the child process, executed this line, I don't want it to execute anything afterwards. So I'm just gonna make it return 0 at the end. Okay, because then the code down here, it's only gonna be executed by the parent, which is, I think, a decent architectural decision, let's say. So this is really what you have to do if you use this many pipes, right? You have 6 close calls on just one process. The same thing applies for the next process. Okay, so if we do the same thing here, I'm gonna say, let's actually bring this down a bit. Int PID2 equals fork. If PID2 is less than 0, then we're gonna return an error code. I think it's 4 or 5, the last one that we have. If we are in that child process, so this is in the child process 2, right? The first one was just child process 1. If we are here, then we want to do what? We want to close against some file descriptors, but this time it's going to be different, right? We're going to have to take a look at this, and we're going to have to focus on this guy. So let me actually bring this guy here. We're going to have to focus on this one, and this one, well, uses fd of 1, 0 to read from, and fd of 2, 1 to write to, and everything else doesn't matter. Notice that fd of 0, the whole pipe can be closed. So we can do that. First, let's close fd of 0, 0 and fd of 0, 1. So that's going to be closed. And then we have to close fd of, what was it, 1, 1, 1. We don't need 1, 1. Fd of 1, 1. And we can also close fd of 2, 2, or no, 2, 2, 2, 0, I think it is. Yeah, because 2, 0 is going to be used by the main process. Okay, and then we do basically the same thing as we did up here. I'm actually going to copy the whole thing. So we still read X. This is not the same X as up top, by the way. It's a different X. We read it from the first process, from the first child process. And instead of using fd of 0, 0, we're going to have to use a different one. And this time it is, I think it is 1, 0. And we're going to write to fd of 2, 1. A good way to actually keep track of everything is remembering that anything that ends with of 0 is a read end, and everything that ends with of 1 is a write end. So when you try to read, you're going to have something that ends with 0. When you try to write, it's going to have to end with 1. All right, I'm going to change these so that they are unique, but doesn't, I guess it kind of does matter. Okay, that's 6, that's 7. We write it to fd of 2, 1. That is exactly the same thing. And as we did up here, we have to close the used file descriptors. I have to say fd of it's 1 and 0, and close of fd of 2 and 1. And of course I want to return as well, or return 0, because I don't want nor the first, not the first, nor the second process I wanted to execute here. So I wanted to just finish the execution right here, so that here we are only executing the parent from the parent process. Okay, so now in the parent process, of course, we need to on it as well have to close certain file descriptors, and we can take a look at the diagram. And now we're going to focus on this guy, and we know that we have 0, 1 and 2, 0 to work with, and that's it. So we're going to actually close everything else. So we want to close 0, 0 because we don't read from that pipe. We want to close 1, 0. We don't actually do anything with that pipe, so we can close 1, 1 as well. And we want to close 2, 1 because we don't read on the last pipe. And again, similarly, we're gonna, well, on this main process, we have to start the cycle somewhere. We cannot just read it because there's nothing to read. The main process is gonna write first. So it's gonna send this X to this first child. I'm going to say fd of 0 of 1. I'm going to say write of fd of 0 of 1 an x that we haven't defined yet. We should actually define here x. I'm going to initialize it to 0, and then I'm going to say size of int, simple enough, and if it gives out an error, please do return an error code, something like 8. Okay, so we wrote that, and once we wrote into that pipe, we should be able to read in the other pipe, in the fd of 2 of 0, I think is left. So read of fd, let me actually bring this down a bit, fd of 2 of 0 into x, it's fine, and size of int, and again error check this. If this is less than 0, then return an error code. And lastly, once we have finally read everything, once we have finally got this x all the way back to the main process, we want to print it out on the screen so we know that the result is right. So I'm going to say here result is %d\n and then x. And of course, as like all the others, we're going to have to close all the other used file descriptors. So fd of 0 of 1, we used that here, and fd of 2 of 0 has to be closed. And because we're in the parent process, right, because of these arrows, we have to also wait for these processes to finish its execution. So I have to call waitpid on them. So null of 0 like that, and waitpid of 2, same exact thing. All right, now what's gonna happen if I try to launch this process? If I launch it, I'm going to get result is 10. Well, that's because x is 0, and we first wrote into fd of 0 of 1, and fd of 0 of 1 is the right end of fd of 0. So fd of 0, we read from fd of 0 here, therefore it gets added 5 to it. Then we write into fd of 1 1, so we should read from fd of 1 0 here, and we add another 5, so it gets to be 10, and then we write to 2 1, which then gets read in the main process at 2 0, and then we print it on the screen. Of course, we can actually like have this as an input. Why not? Let's change this so that it's actually an input. Input number like that, and scanf. We want to scanf %d and the address of x. And now if I actually launch this, it's gonna wait for me to type in a number. Let's say, I don't know, let's say 12, and the result is 22. It just adds 10 to it. Now what I wanted to make you realize in this video is that all the file descriptors opened in a process, when you fork, when you do the actual forking, they get duplicated into the other process. Okay, so this is why we end up with 18 file descriptors, and this is why we have to close 18 or to call close 18 times. An exercise for you guys is, well, notice how this is very similar, right? We have an x, we have a read, we have a write, we have an x plus equals 5 and everything. Try to generalize this program. Try to have, instead of just 2 processes, have n and have a for loop on them. And if you do that, I want you to actually try and count however many pipes you need and however many file descriptors got opened in this whole, well, all these processes in total, right? In here we had 6 file descriptors because we had 3 pipes. In total we had 6 times 3 because we had 3 processes all inheriting those, right? So this is why we got 18 close calls. I hope this was useful. If you do have any questions, leave them down in the comments below or on our Discord server. Take care. Bye.